Hello everyone. In this video, I'm going to continue going over some of the practice test questions. So this is the part about list indexing, including item assignment and nested lists. Okay, let's look at this example. So we have a list of lists. There are 4 sublists in this big list. And we're looping through, it looks like indexes. So range len L. The length of L is 4 because there are only 4 entries in L. It's those 4 sublists. So I is going to go through 0, 1, 2, 3. So to begin here, I'll make a note that I is going to start off as 0. And then it looks like we are redefining, so this is going to be L0 is getting redefined to be L, this is going to be 0 again, 0 plus L0, 1. Okay, so it looks like we are indexing into the list L. We're grabbing the 0 entry, which is the list 47, and then we're taking the 0 entry from that, okay, which is going to be 4. And then we're doing the same thing. We're taking the 0 index sublist, which is 47, and then we're taking the 1 index entry from that, which is 7. And then we're just adding those together. So we're going to get 11, and that is what L0 is being assigned to be. So the new value of L0, that whole 0 index entry in L, is now just going to be 11. So what's going to print out here? So for things that are printing out, the first thing is we're going to print out L with the 0 index entry changed to be just 11. So it's not a sublist anymore, it's just 11. And then the rest of the entries, I'll just copy paste them. These are the same as before. Okay, and so now we did the code inside the loop, so we come back to the top. Now I is going to be the next value, which is 1. And I'll just come down here to the next line and make more comments. So now we're assigning L1 to become L1, 0 plus L1, 1. So basically, we're just doing the same thing that we just did, but we're doing it with the L1 sublist. So the index 1 sublist here, 5, 10, we're just adding those 2 entries together, and we're getting 15, and that is what L1 is being replaced with. So for our next printout here, the index 1 entry of L has been replaced with 15, like that. And at this point, hopefully you guys can see what's going to happen without like needing to write them all out. It's just going to continue like this. So the next printout will have replaced the index 2 entry with 6 plus -2, which is 4. And then on the next one, we will have replaced the index 3 entry with 7 plus 13, which is 20. Okay, and that is what it's going to print out. Let's double check. Okay. Oh yeah, I forgot Python always puts spaces between list entries. Don't worry about that. I'm not going to count off on that. All right. So the next question, we have a list of lists to start off with. It looks like maybe a grade book. And we are going through S in X. So when you're looping through whatever this variable is called, if it's in X, then the variable is going to take on the values of the entries in the list. So this entire sublist here is the first entry in the list. So that is going to be the first value that S is going to take, is that whole sublist. All right, and then we are just, and then we are just printing out these 3 things here. So down here in the printed stuff area, the first thing that's going to print out is S bracket 0. So the 0 index entry of S right here. So that's going to be Anna. And then because we're printing more things, we have this comma here, we get a space, and then we have the word scored, and then another space, and then the -1 index entry of S. So that's the last entry, 77. So we see Anna scored 77. All right, and then we come back to the top of the loop here, and we go to the next entry in X, which is this next sublist here with said. Okay, and then we're just doing the same thing. We're printing the 0 index entry, which is said, and then scored, and then the last entry, 79. This is going to be said, scored, 79. So you can see what this code is doing. It's just printing out the entries, some of the entries from the grade book. So the last value for S is going to be this last sublist. And we're just going to do this the same way. So E squared 87. Okay, let's run this and make sure. Yep. All right, the last one looks like we have a tic-tac-toe board. So it's a list of lists, 3 sublists, and then each sublist has 3 entries in it. And we are looping through range 3. So M is going to become 0, and then 1, and then 2. To start off with, M will be 0. And then we are printing, so this is a little bit tricky here because there's a whole bunch of stuff. Okay, so maybe I'll make some notes like right here. Okay, so it's going to be board 0, 0. And then we're doing that plus board 1, 0. And then we're doing that plus board 2, 0. So we need to look up what these are. So board 0 is this first sublist, and then we are taking the 0 index entry from it, which is X. So we're doing X. And then board 1 is the second sublist, the index 1 sublist here. And then we're taking the 0 index entry from that. So that's this X right here. So we're doing plus X. And then same thing here. We're taking the index 2 entry from board, which is this sublist. And then we're taking the 0 index entry from that, which is this X right here. So we're just doing plus X again. And then, so this is when you do plus between strings, you're just gluing them together, concatenating them. So this is just going to be XXX. And that is what is getting printed out. Okay. And now that we've done one, hopefully you guys kind of see the pattern here. So what's going to change on the next one is instead of doing the 0 index entry here, we're doing, so M is going to become 1. So this will be board 0, 1, 1, 1, and then 2, 1. But we're still going into each of these sublists. This is board 0, this is board 1, this is board 2. And then we're grabbing out the 1 index entry. So the O, and then the X, and then the O. So this is going to be O, X, O. So you see this code is basically just printing out the columns of the tic-tac-toe board instead of the rows. So this is O, X, O. And then for the last one, M is going to become 2. And then we're basically just going to do the same thing, except this time M is 2. So right here is going to be a 2, and a 2, and a 2. So we're going into each sublist, board 0, grabbing out the 2 entry, board 1, grabbing out the 2 entry, and then board 2, grabbing the 2 entry. Okay, so it's going to be X, O, O. All right, and let's check by running it. Okay, so that's it for that section. Not too bad. Next part is list methods, including append, remove, index, insert, pop, and del. So you want to make sure that you study what all of these do, regardless of whether they were on this actual practice test. So append is for tacking things on to the end of a list, adding an entry at the end of a list. Remove is you give it the value that you want it to remove, not the index, and it removes that value wherever it first finds it, and it'll only remove 1 copy of it. Index is for finding things in the list. It returns you the index of the entry that you're looking for. Insert, you give it 2 arguments. The first one is the index where you want to put something. The second argument is the thing that you want to put into the list. And then it inserts that entry there and moves everything else to the right. Pop is weird. You give it you can give it 0 arguments or 1 argument. If you give it 0 argument, it returns the last entry in the list and also deletes the last entry in the list. If you give it an index for an argument, it returns the item or the entry at that index, but it also deletes that entry from the list. And then del is, you use it like this. You use it as an operator. It's not a function. And you put the list name with the list index after it, just like right here, and it just deletes that from the list. Okay, so let's go over some of these. So we have a list here called R, which has 4 entries. Each one is just a single letter. And we're doing a while loop. So while R0 is greater than R1. So it's basically like while first entry greater than second entry. So we're going to be comparing these first two entries of R. So let's think about whether that is true right off the bat. Is D greater than B? Remember, when you're comparing strings, you are comparing them in alphabetical order. So this is going to start off true because D is greater than B. Okay, so we'll go ahead and do the loop. So we're going to append R0 to the end of R. So R is going to become, it's going to be the same as this, but we're appending like a copy of R0 to the end of the list. So it's going to be like that. And then we're removing R0. So it always removes that entry from the first place that it finds it, searching from the left. So R is going to become, we're going to be removing this D from the first place that we find it, which is this one right at the beginning. So that is going to be deleted. So you see basically what happened is we moved the first entry to the end of the list. And then we're going to go ahead and print that out. So I'll just copy that. Print stuff. That there. Oops. In the comments. Okay. And then now we got to go back to the top and we check if this condition is still true. So now we're checking, is this 0 index entry greater than this 1 index entry? So it is, because B is greater than A. Okay, so we're going to do this code again. So now R is going to become, I'll just put it in like an extra thing to the right here. So now we're going to append R0 to the end of the list. So R0 is B. We're appending an extra copy of that to the end. And now we're removing the first place where we find the value of R0, which is that first entry. So this B is going to be gone. Okay. And now we're printing out the new value for R here. Okay, and then we go back to the top and check if this is still true. Is the 0 index entry greater than the 1 index entry? Now it's going to be false because A is not greater than C. So A not greater than C. Okay, and that's it. There we go. Okay, next one here. So we start off with Y is this string, but don't forget to read all the way to the right here because we're doing this string and then we're actually running this method on it. So Y, in fact, is going to be not the string here, but what you get after you call dot split on that string. So it's going to be a list with the things that are between the substrings that are between white space. So it's going to be like this: something new, something borrowed, something blue. Okay, so that's what Y is going to be. And then we're doing another while loop while something in Y. So when you use in on a list, it's checking for any entry that matches that thing that you're looking for. So we do have some entries that are something. We have 4 of them. So we're going to do this code. So I is going to be assigned to be y.index something. So we're going to go into Y and we're going to search for the first entry from the left that is equal to something. And this is going to return the index. So the first place we find it is at index 0 right here. All right, and then what happens is we're calling del y0 because that's the value of I. So we're deleting the 0 index entry of Y. Then Y is going to become same as before, but basically with just this 0 index entry deleted. So it's going to become that. And then we are printing that out. So printed stuff. So this is the first thing that prints out. Okay. Now we go back to the top and we check if this condition is still true. Oh, I should have put some notes here. So first it was true. Now it's going to be true again because we still do have something in there. So we're going to go and we're going to look in Y again and find the index of the entry something. And now the index for the first place it appears is going to be 1. And again, we're just going to delete that entry where we found something. So you guys basically see what this is doing. It's basically just deleting every occurrence of something like one by one. So for the next one, It's going to delete this one. Okay, and then we're going to print out y again. So we're going to be printing this. And hopefully you guys got the pattern of like how this is working by now. So I'll just put some etceteras and you guys can continue the pattern. We're just deleting each occurrence of something one at a time. Okay, and then once we get down to this version right here, we're going to finally get false for this condition up here, something in y. Once it returns false, then we don't run it anymore. Okay, so we deleted all the somethings one by one. Okay, last one in this section, z is a list of the numbers 1 through 5, while z0 not equal to 3. So while the first entry here is not equal to 3, so the first time this runs, that is true, because the first entry, the 0 index entry, is not equal to 3. So while that's true, we're going to do this code here. It's a little bit complicated because there's two things that are happening. So this part inside the arguments has to be evaluated before we can run this outer part. So the arguments always have to be simplified before they can be plugged into the method or the function. So z.pop, that is going to be called first. And when there's no argument to pop, it is going to pull the last entry in the list. It's going to return it. So in other words, we are going to plug in 5 right here to the insert function, but it's also going to delete it. So what this is going to do is basically the same as doing z.insert 05 and then also calling like del z last entry. Okay, so let's think about, so this is going to, let's think about how this is going to change z. What's the new value for z going to be? So we're popping off this 5, which means we're deleting it, but we're also inserting the 5 at the index 0. So the 5 is actually going to come up here to the front, and everything else gets shoved to the side. Okay, so the argument order for insert is first the index where you want to insert, and then the thing that you are inserting. Okay, and then we are printing the new value for z. So printed stuff here, first thing is going to be this. Okay, and then we come back to the top of the loop and we check the condition again. The 0 index entry of z is still not 3, so this is true. And then we're just going to do the same thing. We're going to pop off the last entry of z and we're going to stick it in the 0 index spot. So z is going to become, we're going to take this 4 here. We're going to insert it in the 0 index entry and move everything else to the side. And then we're going to print z. All right, and then we still have that the first entry is not 3. So this is going to be true again. All right, so we'll do the same thing again. We are popping the last entry of z, and we're inserting that in the 0 index spot and moving everything else to the side. And now we're printing z. Okay, and now finally when we come back up to the top of the while loop, this condition will be false because z0 does equal 3. So it's not true that it doesn't equal it. And at that point we are done. Okay, so that was it for this section. Also not too bad. So on to accumulator pattern to create lists. So we're going to be doing a lot of appending in this part. So we have a list called K with the words how now brown cow. And then we have an empty list called L, so that is probably the one that we're building up. And then we're looping through X in K. So the first value for X is going to be just going through all the things that are in K. The first thing is how. And we are going to L and we're appending the length of X. So L is going to get a new entry at the end. And since it didn't have any entries to start with, that'll be the only entry for now, which is the length of X. And so X is a string, so that's going to be 3 for the number of characters in the string. So that'll be the first value for L. And then we're just going to print that. Okay, now we come back up to the top and we go to the next thing in K, which is going to be now. Next entry in K is now. And again, we're just appending that to the end of L. So the length of that, rather. So the length of X is going to be 3 again, and that's getting appended to the end. And then, oops, I should have printed this as a list the first time. And then we're going to print the new value for L. Okay, then we come back up to the top. The next value for X is the next entry, and K is brown. And then we are appending the length of X to the end of L. So we're sticking on this new entry at the end that is going to be 5, the length of X. And then we're printing this out. Okay, and now for the last time this runs, the last entry in K is cow. And we're going to go to L, and we're going to append the length of X to the end of L. So that's going to be 3. And then we are printing L. And that's it. So we just made a little list of all the length of the words that are in K. Okay. So next problem. We start off with a list called S, which begins with 1, 3. And then we're checking the value of the last entry, the index -1 entry. So that's going to be the last entry in S. So the first time this runs, 3 is less than S. So 3 is less than 12. So we are going to go ahead and do this code. So we're tacking something onto the end of S. So S is going to be updated with a new entry at the end that is going to be the last entry plus the second last entry. So you go back 2 entries and add those together. So S minus 1 is 3, S minus 2 is 1. We're adding those together and we're going to get 4. Okay, and then we're printing out the value of S. Oops. So first value is going to be 134. Okay, then we come back to the top of the while loop and we check if the condition is still true. So it is still true because the last entry 4 is less than 12. Now we're going to do this append line again. So we're going to update S by appending a new entry that is S minus 1, which is 4, plus S minus 2, which is 3. So we're going to add 7 to the end. And then we're printing out this new value for S. Okay, now we come back up to the top and we check again, is the last entry less than 12? This is true because 7 is less than 12. And we're just going to keep going like this. You guys see the pattern, right? We're just adding together the last 2 entries and tacking that to the end. And we're printing out the new value here. So I think this is going to be the last time it'll run. 11 is less than 12, but it's not going to be true after this anymore. So S gets one last new entry, which should be 18. And then we're going to print that. And that should be it, because then 18 is not less than 12, so we stop at that point. Okay. Last one, we have a string called S, which is code, and an empty list T. And we are looping through indexes of S, it looks like. So range len S, len of S is 4. So range of 4 is going to be 0, 1, 2, 3. So all the indexes into this S string. And it looks like we are appending onto T. So our first value for I is going to be 0. And we're doing T.append. So we're going to add an entry to T, and the entry is going to be just whatever's inside append. Even if it looks weird, that's what you're appending. So the new entry is going to be like this. This will be 0. This will be 0. And then what is actually S bracket 0? That's the 0 index character from S, which is C. Okay, so we are appending a sublist to T. It's a little bit weird, but I mean, it says right here, that's what we're appending. Okay, and then we're going to print out the new value for T. So it's a list with one sublist. Okay, then we come back to the top, go to the next value of I, which is going to be 1. Okay, so now we're adding another entry to the end of T. So this is what we had before, and now we're going to add, again, I'm just going to like copy whatever was inside append. I'll replace value of I, this is 1, value of I here is 1, S bracket 1, that's the index 1 character from S, which is an O. Oh, I should have put these in quotes, sorry. Actually, did you know you can select things like this and then hit the quotes and it goes on around them? Yeah, I just found that out the other day. Okay, so this is the new value for t here. We're going to print that out. Okay, come back to the top. Next entry, or next value for I is going to be 2. And hopefully you guys see what's happening here. Every time we're just appending a new sublist that starts with I, so this will be 2, and then the index 2 letter from, S. So you guys can see we're almost done. Okay, and last value for I is going to be 3, and t is going to be updated. I'll just put it down here since I don't have more room. So next sublist to be appended is I, comma, S3, which is E, and that is the last value that t gets. Just making a little list of indexes and characters. And that's it. Okay, so that is it for the reading code section. And let's go ahead and look at some writing code questions. So in the writing code part, on the real test, I'm going to give you a lined area that'll have vertical lines as well as horizontal lines, and you can use those vertical lines to help you align your indentations. I do take off for not aligning your indentations. I'm not requiring you to do this so perfect that you have like a ruler lined up, but most of the time it's pretty clear when people did the indents wrong. They sort of intentionally moved like a long space and it was wrong. Here again, it's just the main topics that are going to be on it. So let us go ahead and try the first one. So write a program that asks the user to input their 5-digit zip code. The program should use a while loop to continuously ask the user for the zip code until the user enters a string of 5 digits. Do not convert the user's input to an integer or a float at any point. Yeah, it is best to avoid conversion unless you absolutely have to, because, you know, trying to convert inputs to an integer or a float can potentially crash the program. So we want to find a way of checking that doesn't involve doing that conversion. So first I'm just going to ask the user to enter it, and then I'll think about how to check whether they did it right. So we're going to use the input command. So input, enter your 5-digit zip code. Okay, oops. All right, and then for these validating input questions, you always, well, typically you do it as a while loop, and you're going to check some condition, and then as long as that condition is true, you basically keep asking them. So the thing you want to check here is like while they did a bad job, like while they did it wrong. But how do you write the condition that represents that they did it wrong? So in this case, we have some string methods that can help us. So one thing that would indicate they did it wrong, well, actually, sort of as an overall strategy, you can just put a not here and then list whatever conditions for them doing it right, like while not they did it right. Sometimes getting it right is easier for people to describe than getting it wrong. So while it's not the case that they did it right, we'll just keep asking them. But how do we describe what would be true if they entered the 5 digits correctly? So one thing would be that the length of their input would be 5, like exactly 5, no more, no less. So we can check that, but there's probably more stuff, right? Like we need to also check that they only entered numbers. So there is this method called is numeric. So that's one way to do it. This should work. Let's try. That's a bad one. That's a bad one. That's a bad one. Yep, and then it would stop after there's a good one. If you didn't remember that this existed, I guess, another way you could do it, gosh, it's a little bit tricky to think about. I guess you could do something like check each digit one by one, like make sure they're in this. Like that's kind of annoying to do, but yeah, especially like without a loop. But that might be another way to do it. I do think that definitely zip dot is numeric would be the easiest way to do it. Yeah, checking each letter one by one would be fairly obnoxious. Because you have to write out the whole thing, like zip 0 in 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Maybe you could do it like a little bit more easily by like making a digits string like this and then just referring back to it by name. So you could do something like zip 0 in D and zip 1 in D and zip 2 in D and zip 3 in D. Like, this is fairly obnoxious. You guys agree, right? So this is like an alternative way to do it. Let me put like a copy of this here so people can see, if they want to, that this is another way to do it. Not a good way, I would say. I'll just label this as like alternative method. Okay. Maybe I'll use this for alternative method. Okay. Anyway, hopefully you guys understand what I'm doing here. All right, let's look at the next one. So write a function called excerpt that accepts one parameter. How do I get rid of this little thingy? Click somewhere else. I guess I have to scroll up. Okay. Write a function called excerpt that accepts one parameter, a string called passage. The function should use the dot split method and the accumulator pattern for strings to create a new string that contains as many words as possible from the beginning of the passage, while making sure that the new string is 100 characters or less. So here's an example. This is the first sentence from the Declaration of Independence. Obviously, it's longer than 100 characters. So if we had that for the value of passage, then if we go all the way through the word bands, that's 103 characters. So that's like one word too long. So you would instead only go through the end of the word political. So that's the longest substring of whole words that you can include without going over 100. Okay, so you want to have as many words as possible from the beginning of the passage while making sure the new string is 100 or less. Okay, so like you're not going to cut off in the middle of words. Okay, so we are defining a function. So this is def excerpt. The argument is called passage, and we want to return our excerpt. So we need to use, it does say to use the dot split method and the accumulator pattern. So I'm going to define a variable that stands for the thing I want to return. Maybe I'll call it like E for excerpt. So I'll start that off as an empty string. And then I also need to split the passage into a list of words. So I'll just call it L, my creative thing that I call every single list I ever work with. So we're just going to do split with no arguments. That'll split at the white space. Okay, and then what is it that I want to do here is like basically keep adding entries from L to E until I get past 100. So I could do something like this, like while len E less than 100, basically keep adding the next word, like E equals E plus L. Oh, how do I even get the last word out of L? Okay, that's a little bit tricky. I guess I'm going to have to loop through the indexes of L. So maybe what I want to do is like for I in range len L, like this. That's going to take me through every single index that could be an index into L. But I guess I could just like break when I'm done. Stop going through all of them. So I want to add the ith entry to L, or sorry, the ith entry of L to E. So if I just do it like this, like let me show you guys what will happen. And let's try calling this example. So we can use the example string here. It's just gonna, oh, we forgot to put spaces in between them. I didn't even think of that. Basically it just keeps going until you get all the way to the end. So we need like a way to make it stop. And I also need to put spaces in. Let me put a space between every word. Okay, so it's just keeps going all the way, adding one word at a time until we get to the end of the passage. All right, so how do I make it stop? Yeah, so if I guess if I want to, if E gets too long, I should stop. Len E greater than 100, break. Let me put the print before that. So break will just make the loop stop. Okay, I think this is not going to work though, because yeah, it goes all the way through bands, which is further than I wanted it to go. Because in the example here, bands is actually too far. We wanted to stop at the word before that, which is political. So this is a little bit tricky actually. So I think what you can do is basically do this check and break thing. Well, you could try to like put this, below, like don't add the word unless we already passed this test here. But the problem is I don't think that'll change anything because we don't know that we went past 100 until we already went too far. So that's a little bit tricky, right? So you kind of have to like look ahead and see what is going to happen to your length before you actually go ahead and add the word to E. So I think what we need to do is like look ahead and check before adding to E. So let's think about this a little bit. Okay, so what I want to do is basically I want to check like if adding the next word is okay, then add the next word. Like that's the concept of what I'm trying to do here. So I know how to add the next word is just like update E to be E plus LI and then plus a space. But what's a little bit tricky is checking whether adding the next word actually is okay. So what is it that I'm trying to do here? I'm trying to check if the length of E plus next word is less equal than 100. That's what I want to check. So how would I do this? Length of E, so like length of current value of E plus the next word. Well, actually, this is not so bad because I do know how to find the length of E, right? That's just len of E. And I know how to do this plus next word. So I can just literally do just like plus len of the next word. That's it. And then I just want to check if that's less equal than 100. Okay, so if the current length of E plus the length of the next word is less than or equal to 100, then that means it's okay to add the next word. So I would go ahead and add it. And let's print these out now and make sure it's working. So it should stop at political. Wait, what? Why is there a TO at the end? What? Political 2? What? What is happening? Oh, okay. I had to pause this for like a few minutes and see because I didn't understand. Right. So the thing is, this loop here, this for loop, is still going through every single word in the passage. And basically, it's just checking, like, is adding that word going to make our excerpt too long? And if it will make it too long, then it won't add it. But if it won't make it too long, then it will add it. So basically, like, after we got to, let me go back up here. After we got to political, that was 97. So adding bands would make it too long. So we don't add that one. But then it just like keeps checking these other words and they all would make it too long, but it never stops like checking them. So then when it gets to 2, it's like, oh, that won't make it too long. So it goes ahead and adds that one. Okay, so what we need to do here is also like, if we find that the length would be too long, then we actually need to break the loop. So what we need to do here is like have an else condition where we just break the loop. So I think that will work. Let's double check. Yes, that looks like it is working. And now I'm going to take out this print part here because I don't want to actually print. What I want to do is return the excerpt. So at the end here, I'm going to return E. And let's go ahead and print the call to the function down here and make sure it's working. Okay. I think this is a really hard question, actually. It's probably the hardest one on the practice test. It might even be too hard for a real test. But I do think it's a good learning exercise. And I also definitely think there's other ways to do it other than the way that I did it. Generally speaking, like having a break in a loop kind of doesn't feel like great programming. It always kind of feels like I could have done it a better way than with breaking. I think we definitely could have made this work with a while loop as well. But conceptually, this is like the right, more or less, approach, is like go through all the words, check if adding that word is going to make the excerpt too long. If it doesn't make it too long, then add it. If it does make it too long, then you're done. So stop. Okay, so go on to the next question. So the triangular numbers Tn are a sequence that describes how many dots are required to draw a triangle of dots with n dots on each side. That may not make a ton of sense, but just like Google what they're supposed to look like. Anyway, the point is that the values are like this. So the first few values, T0 is 0, T1 is 1, T2 is 3, T3 is 6, T4 is 10, and so on. And the main thing you need for this particular question is this rule right here of how you get the next one in the sequence. So they obey the rule that T1 is T0 plus 1, T2 is T1 plus 2, T3 is T2 plus 3, and so on and so forth. So you see what the pattern here is like each T sub I is T, like the previous one, Ti minus 1. Oh, how do I do? Let me see. Plus the actual index, if that makes sense. Is that going to subscript correctly? Oh, no. Suddenly realized I don't know how to do fancy subscripts in Markdown. Oh, yes. Okay. That's it. So basically the idea is like to get each Ti, whatever index you're trying to get the entry at, you just use the previous entry plus the current index of the entry. Okay. And so we're going to use the accumulator pattern for building lists to create a list T of the first 10 triangular numbers. And to be clear, what I mean by a list of them is like the 0 index one should be 0, the 1 index one should be 1, the 2 index entry should be 3, and so on. Okay, so we're not going to type these out. We're going to use the accumulator pattern. So I'm going to start off with an empty list for T. And I guess I want to do some sort of for loop for I in range. Well, I'm trying to do the first 10, right? So I'll do range 10. Now, this is a little bit tricky because I can't just do this kind of thing. I can't do an item assignment to different indexes when T is actually starting off empty. So I need to do T.append instead. But how I do T.append, so I think maybe I need to start off with one entry before I can use this pattern of each one being the sum of the previous one. Maybe what I want to do actually is start here with 0. And in that case, I'll go from range 1 to 10 instead of 0, 10. Or rather, this is going to be 1 to 9. Okay, so I'm going to do T.append. And I think I just need to append the previous entry in the list. So that'll be T index minus 1. Right? It's always the previous one. And then plus the current index. And that's what I'm calling I. So I is going to go, stop that. I is going to start at 1 and go up through 9. So let's run this and see if it's actually working. Oh, sorry, it's supposed to be at plus. Okay, yes, these are the triangular numbers. So it's 0, 1, 3, 6. We know those are correct. So basically it's like from here to here is plus 1. From here to here is plus 2. From here to here is plus 3. This is plus 4, plus 5, plus 6, plus 7, plus 8, plus 9. Okay, so that's it for that one. It's not too bad if you understood the problem. All right, number 4, write a function called insert alpha that takes 2 arguments, a list L whose entries are strings, and a string S. Okay, I can go ahead and do that part. So def insert alpha ls. Okay, it is assumed that L is in alphabetical order. Okay, L is this list of strings in alphabetical order. Okay. The function should modify L by inserting S where it belongs in alphabetical order. The function should not create any new lists and should not return anything. So for example, if L was arm, bug, cat, eel, and S was dog, the function should modify L to become arm, bug, cat, dog, eel. Okay, so you want to start, I should have maybe emphasized this more in this one back here, but you always want to start by thinking about how you would do this task as a human and then try to break it down into really tiny, tiny little steps. So how I would do this task as a human is basically I would go through each entry of L one by one, and then I would check if S should go right after that entry or right before that entry. Right before that entry. Yeah, that's pretty much it. So go through each entry of L one by one. So like if I were doing it with this list right here, I would be thinking about the word dog and I'd be saying, should dog go before arm? No, dog goes after arm. And then I'd look at the next one. I should go, does dog go before bug? No, dog goes after bug. Does dog go before cat? No, it should go after cat. Does dog go before eel? And then I'd be like, oh, yes, okay, it does. All right, and that's pretty much it. So there's a few ways to do this. You could do it with a for loop through the entries of L. The behavior I just described pretty much sounds like a for loop, but you just want to make the loop stop as soon as you've inserted. Or you could do it with a while loop. For the condition of the while loop, I guess you could just check if you've already inserted it or not, or you could also use break. I think I'm just going to do it with a for loop. So like for word in L. Okay, so I'm going through each word in L one by one. So now I'm going to do this part. So check if S should go right before that entry. Oh, and then I forgot to mention, like, once I find that it should, then insert S before that entry, and then stop. All right. So this is what I would do as a human strategy. Okay, so forward in L, if S goes before, so S is less than that word, then I want to insert it. So what am I going to do? S or L dot insert. Okay, so now here I run into a problem because I don't know what index I'm at. So there's a couple ways to solve this. I could back up and instead of looping through the entries in L, I could loop through the indexes into L. Or I could like try to find the index by using I equals like L dot index, search for where the word was at. I think just looping through indexes will be easier. So instead of for word in L, I'm going to do for I in range len L. And then instead of checking whether S is less than word, I'm checking whether it's less than the I index entry into L. And so if it is, then I'm going to insert S before that entry. So basically that means I want to put it where that entry is at. So at the I index entry is where I'm going to put S, and then everything else gets shoved to the right. Okay, and then if I've done it, then I want to stop. So at this point, I would break. Okay, so let's do some testing down here. So we're not returning anything. We're doing modification in place. So I'm going to start off by defining this list L and this value for S. Oops. And then we're just going to call the function, but we're not going to save anything from the call. So we're going to do ls. And then we're just going to print out what L is now to see the new value. Yep, it looks like it worked. Let me try some other values here. Like if I did aardvark, it should go at the beginning. If I did something that comes after bug and before cat, I don't know, cactus. Yeah, okay, it looks like it's working. All right. So I definitely think you could do this with a while loop as well. This is just the first strategy that I thought of. All right, number 5, consider the list of strings L in the code block below. Each string represents one CSCI section being offered at SU in the spring. I actually think these were from the fall. Each string has 4 parts separated by commas. So the first part is either open or closed, depending on if there are any seats available. The second part is the name of the section or the code for the section. The third part is the number of students enrolled in the section. And then the fourth part is the number of credits that the class is worth. Write a program that uses the accumulator pattern to find the total number of students in all of the sections. So basically what we have to do here, let's write down a little human strategy again. How would you do this if you were human? So what you would do is like go through each entry in L, get the number of students from it, add them up, right? That's pretty much it. So we know, because we've done some coding already, that like it's slightly more complicated than to just add them all up. For that, you have to use the accumulator pattern, meaning start with a total of 0, and then for each time you get the number of students, you add that to the total. So you have like this rolling total. Right, so let's go ahead and start that off. So we're gonna have a total of 0. And then we're gonna go through each entry in L. So like for, I don't know, let's just call them entry in L. And then now we have to somehow get the number of students from the entry. So the first value for entry is going to be this one. How do I get the 17 out of this? It's kind of tricky. So you're going to need to use the split method for strings. So I want to call entry dot split, but I'm not splitting at white space. I want to split at commas. So I'm going to put a comma in quotes here inside of split. And I need to save the result of this call somehow. Maybe I'll call it, I don't know, data, give this a name. So data is going to be a list of everything that was between commas in the entry. So the first entry will be open, and then CSCI-181-24SP, and then 17, and then 4. So the index of the 17 entry is going to be 2. So the number of students is going to be data bracket 2. Okay. And then we're going to add that to the total. And that should be it, except I already know there's something wrong. Let me show you guys what's wrong with it. Unsupported operand types, int and string. So when you get that 17 out, it's going to be a string. You do need to convert it to an integer, like this. Not a huge deal, but yeah. So let's make sure this is correct. So this should be 17 plus 4 is 21, plus 5 is 26, plus 29 is, let's see, 40, 55, plus 5 is 60, plus 75, let's see, 88, 98, 106, let's see, 116, 120, 122. Yep, that should be right. Okay, so next question. For the same list L as the last problem, write a program that makes a new list whose entries are just the names of all the sections. You can use the accumulator pattern or list comprehension. So the new list should start like this, CSCI-151-01, and so on. So I'm going to actually pull the code from the last one, and let's look at whether we can reuse it. So we don't need a total, but what we do need is a new list. I'm just going to call it M instead of L because I'm real creative with these list names. And I'm going to start it off as an empty list. And then I'm going to go through each entry in L, and the splitting thing here is still good. But now what I want to do is not add the number of students to the total. What I want to do is append something to to M, my new list. I need to append the entry from data that corresponds to the class name. So that's going to be the index 1 entry. So I'm going to append data bracket 1, and then let me print this out when I'm done. So see if I did it right. Yep, looks good. So that one is not too bad. If you wanted to do it with list comprehension, I think it's a little bit tricky. So you'd want to do it like, let me call this one N. So you write the form of what the entries are going to look like, which I'm not sure about that for now. And then you put the loop part over here, so for entry in L. So the trick is to write what each entry looks like without multiple lines being needed. So instead of, so I know my entries look like this, right? Data bracket 1. But data has no meaning here. I haven't defined data as anything down here. So instead of using data, I need to put this thing, entry.split at the commas, and then take the index 1 entry from that. So that would work, I think. Let me try this. Yeah. A little bit trickier to do it that way, but technically it's shorter, it's fewer lines of code. The thinking part is harder. Okay, next question, number 7. Write a function called mdy that takes one argument, a string. So mdy s, which is a date in the format YYYY such as 2023-09-01. The function should return another string, which is the date in the format MMMD YYYY. Okay, so basically we're going to replace the numbered month with the lettered month. And we're going to pull out the date, and we're going to take off the 0 if it has one. And then we're going to put the year at the end. So this is kind of tricky. So one way to approach it, just doing it as a human, is like, how do I get this information, the SEP? Well, to get the SEP, I need to get this 09 first. So how do I get the month number? How do I get that out of S? So one way to do it could be with slicing, because these are in a very specific format. This is always going to be in the same 2 indexes there. So this is going to be index 0, 1, 2, 3, 4, 5, and 6. 5 and 6 are the ones I want. So starting at 5 and then stopping before 7. So that'll give me the month number. And then I guess I need to convert that to an integer, do I? And then how do I convert that to an actual 3 letters, like April, June, whatever? So for that, you're probably going to want to use a list of months, month names, like month list, you can call it, and then have them all listed out like this, and then you can index into that using the month number. So Jan, Feb, March, April, May, June, July, Aug, Sep, Oct, Nov, Des. Okay, but if I do the index 9 entry from this, it's not going to be Sep, it's going to be Oct, I think, because they start at 0, right? So it's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So to get Sept, I'm going to want to grab the entry before 9. So for the month name, let's use month list index month num -1. Okay, hopefully that makes sense. Let's print out what we've done so far and make sure it's even working. And I'll have to call this too. So let me call it with the string here. Yeah, so I'm getting Sep. Let me see if I change this to something else. Is it still working? 11 is Nov. Yeah, 12 is Des. 01 should be Jan. Okay, yeah, that seems like it's working. So as long as they don't put something stupid here like 13, then it should work. If they put a wrong month, then it will break. But they didn't ask us to check whether they had done it correctly. They just said assume that it's done correctly. Well, they didn't say anything in point of fact, but okay, let's not worry about that. Okay, so the month name is working. So for the output string, I'll call this output. I want it to start off with month name. All right, so that takes care of getting the month on there. And then for the date part, I'm just going to put a space, and then I'm just going to put the date. And I think I'm just going to grab the date the same way I grabbed the month. So date is going to be int s, and then it's going to be, gosh, oh, it's always going to be the last two, right? So I can use a negative index like this. So starting at -1, wait a minute, it goes from left to right. Yeah, so starting at -2, second to last, and then just going to the end like that. Will that work? Hold on, let me check. Yes, okay. What if I had 2 digits there? Oh, you won't be able to check this on the test, so you might get a little bit in your head about these digits here. You could also just count, so it's going to be like 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So 8 and 9 are the ones that I want. So you could do like 8 to the end, or just 8 to 10 like that. What does it look? Okay, so I want to add the date onto. Oh, and the reason I converted it to an integer was just so it would take off the 0 if it was there. I guess I could have done that with an if statement. In fact, maybe that would be better. Okay, anyway, now I'm going to add that onto the output. So output is going to be output plus, I want to put it back to a string. And let me check what my output is so far. Step 1. Oh, I forgot the space. Okay. Step 1. Okay. Clearly, you guys see this is kind of hard to program without actually being able to test it. All right, anyway, and then I want to also put a comma after that and another space. Yeah, and then I'm going to put the year. So for the year, I don't think I need to convert that to an integer. I'm just going to grab the first 4. So index is 0, 1, 2, 3 from the beginning of S. And that should do it. Oh, right, I forgot to print anything. Now let me put the print around the function call, and we can actually return output. Yep, looks like it is working. Let me try some other dates. Yep, okay, cool. All right, that one's a little tricky to do without actually being able to test it, I think. All right, number 8, write a function called vector add, which takes 2 lists, v and w, as parameters. So this is going to be def vector add v, w. The 2 lists will have 3 numerical entries representing the x, y, and z components of 2 3-dimensional vectors. If you guys don't know what vectors are, it's basically just a list of numbers. The function should add the 2 vectors and return a list of the 3 numbers as a result. For example, vector add 1, 2, 3, 4, 5, 6 should return 5, 7, 9. So like you add the 2 first entries, and then you add the 2 second entries, and then you add the 2 third entries. It's not too bad. But we are going to need to make a new list. So let's call our new list, I don't know, sum. Okay, and I'll start it off as an empty list. You could, I guess, also start it as like one of the vectors and then just add the entries from the other one. There's multiple ways to do this. Now I'm going to loop through the indexes into one of the vectors. Oh, actually, I guess we already know they're only going to be 3-dimensional. So we could just do for I in range 3. All right, and then be a little bit careful because you can't do this because we don't have any possible indexes into an empty list yet. What you need to do is append to the list. So we're going to do sum.append. And we're just going to grab the ith entry from V and add that to the ith entry from W. And then we're just going to return that. So let's go ahead and test this. Just the test case, see if we get 5, 7, 9. And we do. Okay, cool. All right, so the last question for the practice test is write a function called unique characters, or unique chars, that takes 1 argument, a string called s, and returns a list of the lowercase version of the unique characters in the string. Lowercase and uppercase characters should be considered the same, not unique from each other. For example, in the string Susquehanna, the unique characters are S-U-Q-E-H-A-N. So the two S's, even though they're different cases, those are not considered different, they're considered the same. Okay, so again, you want to think about how you would do this as a human. So here's a human strategy. How would you do it? Well, if I was going to do this with Susquehanna, I guess I would start with the S, right? Except I'd make it lowercase, so that's where that S came from. And then I would look at the next letter and I'd be like, okay, that's a new one. I didn't see it before, so I'm going to put that one in. And then I would get to the S and I'd be like, oh, I already saw that, so I don't need it again. It's already in my unique list. Okay, so you see what I'm doing here is like look at each letter of S one by one. And then basically, if I haven't seen it before, add it to the unique list. If I have seen it before, do nothing. And then return the list at the end. Okay, so that's pretty much it. So things that we're going to need here are we're going to need a list to stand for the list of unique letters. I'm really creative, so I'm just going to call it L. And it's going to start off empty because I haven't looked at anything in my string yet. And then I'm going to go through the letters of the string one by one. I know how to do that, so just for letter in S. And okay, so where am I at in my strategy? If I haven't seen the letter before, I'm going to add it to the unique list. So how do I know if I've seen the letter before? Well, I have this list of all the ones I've seen before, right? So I can just go ahead and check if letter in, actually I want to do if letter not in S, I want to check if it's in L. Okay, so if letter is not in L, then I'm going to append that letter to my unique list. Okay, and that's pretty much it. I don't need to do anything if the letter is in there. I'll just ignore this part since I'm not going to do anything. I'm just return this. Now I know there's something wrong, though, and that's that I didn't deal with the cases. Oops, the return should go out here. So I didn't deal with the cases. So how do I deal with that? Because right now it's going to be counting capital S and lowercase s as the same. Well, I could put lower here, like append the lowercase version of the letter, but that's not going to help me with checking whether it's in there, I think. Or will it? I think I also need to check here using the lowercase version. So basically just force the letter to be lowercase. Or here's another strategy. You could just force the whole string to be lowercase at the beginning and then you don't have to worry about it. Ooh, I like that strategy. So just remove case at the very beginning like that. And then everything's lowercase. Okay, let's try testing this. Unique characters. Yep, looks good to me. I'm gonna try with my name. Yep, looks good to me. I think it's working. Okay, so that was the last practice question. If you guys have any concerns about this, send me an email. Otherwise, good luck on the test.